So, happy Wednesday, welcome back. Take our look at the calendar. We have finished our little mini section on voting. We spent 4 classes on voting. Many of you have made very good progress on the project. Some of you have already turned it in. The project is due right here, 25th of September. 1 week from today is when this project is due, okay? 1 week from today. All right, today and next class, we talk about something called weighted voting, and then these things that look hard to pronounce, the Banzhaf Power Index and the Shapley-Shubik Power Index. So the next 2 classes are related to each other, not really related to the stuff that we've done so far, even though we're going to be using the word voting again today. So new topic for today, and then after those 2 classes, we have 2 classes on cryptography, which is all about encoding and decoding messages. Okay, so that's what's coming. So let's take a look here on page 33. And I just want to put it out there from the very beginning. There's a lot of stuff in today's class. It's really kind of cram-packed full of stuff. So we're going to kind of go through relatively quickly and hopefully have some time for you guys to do a group activity towards the end. So number 1, we'll get our reader. Jake, can you read number 1, please? Okay, so here's a picture of the United States, and on top of each state and the District of Columbia is a number. And these numbers represent electoral college votes that each state has every 4 years. And so how many votes do we have? 11. Massachusetts has 11 electoral college votes. What's the biggest number you find here? It's 55, way out there in California. California has the most number of votes at 55. Who's second most? Texas down there at 38. Third? Yeah, Florida and New York both have 29. And you can see that these are not necessarily the biggest states. Florida's not all that big. It's kind of average in terms of size. Why is it so big in terms of the number of votes? It's about population, right? So these numbers right here have everything to do with population. There's a formula that they use involving population. Plus every state gets 2, 1 for each of their senators. So it's, you know, it's just representation based on population. What's the smallest number that we see up here? 3, and there are a lot of 3s. And so we're looking at states that have 3, for example, Delaware, this really tiny state over here has 3, but then you've got much bigger states like Montana and the Dakotas that also have 3. Again, it's not about size, it's about population. So, what's that? And Alaska, which is really big, way bigger than it looks here in this map. So we've got all of these states here, and then every 4 years we all go out to vote. And the fact that Massachusetts is blue means that we voted Democrat at the last election when Obama beat Romney. And what that means is not that everybody in the state of Massachusetts voted for Obama, but that, was it a majority? Did it have to be? I mean, yes, it was a majority. We're very democratic. But we lean towards the Democratic Party. But does it have to be a majority to get? No, it has to be what? It has to be a plurality, right? Didn't need to get a majority, just need to get more than anybody else in the state. And so in this state, Obama beat Romney in the popular vote. He had a plurality of those votes. And so he won all 11 of our electoral college votes. Is that fair? I don't know, but that's the way it is. And so what I want to do is think about what these numbers represent. Clearly, California is more powerful than we are, 55 to 11. But the mathematician in me wants to know, well, is California 5 times as powerful as we are? Right? Because they have 55 votes and we have 11. So they have 5 times as many votes as me, as we do. So I just want to know, is it as easy as just looking at that and saying, okay, California is 5 times as powerful as we are, and us compared to Rhode Island, we're about 3 times as powerful as Rhode Island. I want to know if it's as easy as that in terms of deciding how powerful these different states are relative to each other. So that's what we're talking about today, is power in an example like that. So let's go to number 2, and we are on to Aileen. Thank you. Kate. Okay, so I know we're still using the word vote, but I want to make some distinctions that say that this voting is different from the voting we've been talking about the last 2 weeks. Used to be that each voter got exactly one vote. One person, one vote. Yes? It's not the case here. Whoever has the most shares here gets the most votes, 10 in this case. And then somebody else gets 9 votes. And then the weakest person there gets only 3 votes. So it's no longer one person per vote, it's weighted. Different weights, just like with the states. The other thing here is that we are no longer filling out a preference ballot where we say vanilla, strawberry, chocolate in that order. We are just saying yes or no. These are different questions. We're not being asked to rank things. We are just being asked yes or no. Are you in favor or are you against Obama or Romney? It's only 2 choices, okay? No ranking, no 4 choices, just 2. All right, so let's go down to number 4. We denote a weighted voting system as, and then there's some funny looking notation. It says Q is the quota. So the first number that you see inside that bracket is the quota, is how many votes are required for a motion to pass. And then W1, W2, W3, all the way up to WN, those are the number of votes owned by each of the players in decreasing order. So a concrete example will help make this notation clear. So the stockholder example that we talked about, here's how we write it. What's the quota for the stockholder example is 12. And then you put a colon, just part of the notation every time. And then you just list how many votes each person has from biggest to smallest. 10, comma, 9, comma, 3. Close the brackets, that's it. Everybody understand how to write this down? And the nice thing is it's a really compact way to get everything in this paragraph, number 3 here, written down. That's all we need to know. Okay, and so for our presidential elections, you don't need to write this, but we could write presidential election stuff. I'm going to leave the quota blank for a second, but anybody remember the number for the most powerful state? It was 55. That was California. Texas, was it 38? And then comma, and then we could keep writing. And then what would the last number be? 3. And in fact, there will be a bunch of 3s at the end. The quota? There are 50 states, so 51. It's 2 something. Yeah, every 4 years. I mean, there's no reason for you to have this number memorized because it's only important every 4 years. But every 4 years, you get all these little tickers on the different news shows that say, hey, there's how many votes Obama has right now, and here's how many Romney has right now. And the first person to get to 270 is going to win this presidency. Right. And so, so the quota in this case, so actually there's an even number of electoral votes. I think it's 269 is the halfway point, but in theory could be tied at 269, which is why 270 is the quota. Okay? So that's a way you could write down what happens every 4 years. Race to 270. Okay, number 5, and we are around to Lila. Okay, so we've got these 4 players is why we're calling them P. So P just stands for player. P1 is player 1, just so that we don't have to give them names every time. So the first question is, what's the total number of votes? Okay, let's see if we can answer that. So it says that every 10,000 is 1 vote. How much money is in this company? 200,000. So how many votes are there in there? 20 altogether. So if you want to see the calculation, it's the $200,000 divided by the 10,000 bucks per vote. 20 votes altogether. Okay, next thing we want is the quota. In presidential elections, the quota is just half of the total. There's a total of 540 electoral votes. Half of that, well, it's 538 electoral votes. Half of that is 269. But it doesn't have to be half. We have to make it half in our presidential elections because otherwise we might not have somebody elected if we set the quota too high. But the quota in this case is set at 2/3 of the total. 2/3 of 20 is a decimal. So what do we do? 14? So what is 2/3 of 20, including a decimal? Is 13.333. Okay, but that doesn't make sense. And I guess we're saying more than that, right? We're not rounding here. So it's 13.3 repeating, which really means that 14 is what we need, right? You're not going to get to 13.3. Okay, and then we can write this thing in our standard notation with a square bracket to start. And what's the first number? 14 is the quota, comma, and then we put the strongest person first. How many votes does that 80,000 person have? 8. Every 10,000 is a vote. So that person, whoops, colon, 8 votes for that first person. Next one, 7. And 2. Is there one? I think it's just those 4 people. Yeah. 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 And so you don't need to put this, but I'm just going to highlight. We are just calling, instead of giving them names, we're just calling them P1 and P2 and P3. P4. Okay, number 6, we're going to go back to Brandon. So we're going to use some of those words, but not all. So look at the definitions later on. Maybe you read it heading into today's class already, but check them out later. We'll go to Mary for A. Okay, so let's answer all these questions here. Suppose the quota is set at 10 votes, which is lower than it is right now. 10 votes. Okay, so what that means is that 10 votes are enough to pass a motion. And it also means 10 votes are enough to squash a motion, to stop something from happening. Okay, so suppose that, that this person and this person are in favor, and they both vote yes. How many votes do they have? 10. And the motion passes. But that also means that these 2 people said no, they're not in favor. And how many votes do they have? 10. And so that's enough to squash it. This is a problem. The quota is set too low. You can't have something that's going to pass and also get stopped. So there are rules about like how low the quota can be. 14 is a safe quota. There's no way you can have 2 different groups that both have enough power to get 14, but 10 is too low. Mm-hmm.
Because the way it's voting, for the 8 to 7, obviously they want the quota higher, so, not as high, but you understand, lower the quota, you're throwing the balance.
Yeah, changing the quota affects the power, and we're going to see that today. Okay, next part of this is, what if the quota is raised to 19 votes? 19 votes, that's really high. What has to happen in order for 19 votes to say, yeah, this is a good thing? Alicia? They all have to agree. The only way we're going to get 19 votes here is if they all say yes. Agree? So, for a quota of 19, all have to vote yes for a motion to pass. Yeah, what does that mean about P4? It looks like they don't have much say. They have only 2 votes.
Just as much say with 20 grand as the person with 80 grand gets.
You guys buy that? If we set that quota at 19, then we are requiring a unanimous vote. Everybody has to say yes in order for anything to happen, which means that player 4, even though it looks like they have hardly any power, if they say no, it's a no. And in fact, they have exactly the same amount of power as everybody else. Yeah. So we're going to use this word. The fact that anybody could just say no and that stops it means that they all have one of these things: dictator, veto power, or dummy. It's veto power. When you have the ability to just say, nope, this is not going to happen, I veto it, we'll say they all have veto power. So maybe this was your experience too, but when I was younger, whenever I wanted something, I went to Dad. Dad was an easier sell for me than Mom was. So I go to Dad, Dad would say, okay, sure, you can do that, that's fine. And then if Mom found out about it, she could just say, you know, hey, nope, I veto. Even though Dad said yes, I say no, and she had veto power. And it could be that way in your experience too, but that's what it means, right? Veto power. Okay, what if the quota is raised to 21? Nothing will happen, right? There's only 20 votes in there. There's no way we can ever get to a total of 21, even if they're all in favor. Nothing will ever happen. So we'll say Q equals 21 is too high, since it's more than the total number of votes. When you're ready, we can move to the next page. And let me just ask, is there anybody who didn't get a Math Studio bookmark the other day? There you go. Anybody else? Okay. Oh, you weren't here either. All right. So how about this weighted voting system? 11 is the quota, 12, 5, and 4 are the weights. What can we say about the folks here? Ed, this is a dictatorship. Why is it a dictatorship? Player 1 has enough votes to pass anything. All alone, without any help from anybody else. Player 1 is in complete control. They have 12 votes. The quota is 11. Doesn't make any difference what players 2 and 3 do. So what word could we use to describe players 2 and 3? They are dummies. It's an unfortunate word. It's the word that we use in math. It's not saying anything about their intelligence. I think of it more as like a ventriloquist. What's the name of the doll that the ventriloquist uses? It's a dummy because it just sits there and is controlled by the ventriloquist. So this partnership is completely controlled by that first player. The other 2 are just kind of dummies. They're just puppets that have no say in anything. Okay, so we'll go to Ed for number 7. Okay, so all we're doing is thinking about ways in which players could vote together, could vote the same way. They vote yes, could they vote no? But they're voting together. If everybody votes the same way, that's called the grand coalition. A winning coalition is a coalition that has enough votes to win. Any coalition that has enough votes to win is called a winning coalition. Any other coalition is a losing coalition. One more vocabulary phrase and then we'll actually start playing with some numbers. Mary, critical players? Yeah. So we're going to talk about all these words in this example, but the vocabulary is up there. We can look at it again. Casey, number 8, please. Okay, so 200 total, majority is more than half. Majority is 101. So in order for a motion to pass, we need 101. I didn't ask you to do it here, but can you write down this coalition in our standard notation? Okay, what's the quota? 101, then we put our colon, and then the next number? 3. Good. Okay, so here's what we're going to do. We're going to fill in this table together. This is the new part. This is the hardest part for today. Okay, I want to find winning coalitions. Winning coalitions. So, so I'm going to call these guys red and blue and green. Red and blue and green. R, B, and G in that order. It's also fine to call them P1, P2, and P3, but I'll call them R, B, and G. Okay, so my job is to find all the ways that something can pass. How can these folks vote in order for something to pass? Is there any single person or single party that could vote and it would pass?
No.
No, nobody has enough power just on their own. So now we're going to look at pairs of people. We've already looked at single people, there's none. Now we're looking at pairs of people. What's one pair of colors that could join together? Use the letters R, B, and G. R and B. So one winning coalition is R and B. And we're just going to list the letters there with a comma. I'm not going to require that you do this, but technically we put the little curly braces around the side. That's how we write a set mathematically. I don't need you to do it. What is the total weight of those two together? Yeah, so it's 99 plus 98, which is 197. And how do we know that's enough in this case? Anything more than 101, it passes. So that's why it's a winning coalition. Are there any other pairs of winning coalitions? So we could do red and green. Right? And the total there is 102, which is enough. It's just barely enough, but it's enough. And I don't know if we said this before, but 101 is technically enough as well. So like 101, it doesn't need to be more than. Just 101 is fine. And then B and G does too. Let's see. So B and G, what's the total for B and G? It's 101. So they just barely squeak by, but they can pass the motion, the two of them together. And then we've done all the pairs, and now we're going to look for trios of people, and if all three of them are in favor, then the thing will pass. So we'll go ahead and list R and B and G all together. That's the grand coalition. Everybody voting the same way. And how much weight do they have? 200 altogether. So far, so good? And we didn't put any singles there because no single person could pass it by themselves. We only care about winning coalitions, not losing coalitions. Okay, here's the toughest part of filling in this table, is this idea of critical player. So we'll say again, this is what Mary read to us. A critical player is someone whose votes are necessary in order for that coalition to continue to win. In order for the coalition to continue to win. So how about we look at this first row, and we'll just look at the R candidate right there. So I want to know if it's really necessary for R to be there. Well, in order to answer that question, we just temporarily cross R off. Now how much power does this, how much weight does this coalition have? B has only 98 by themselves. Is that enough to win? No. So in some sense, it's really important that R is there, because if R isn't there, they lose, which is why we call R a critical player. It is critical that they are there in order for that coalition to stay winning. So R is critical. And then we play the same game with B. And so we will temporarily cross it off. I encourage you to just like put your finger over it or something. Just cover it up. How much weight is left here now? 99. Is that enough to pass? No, which means that we really need B here in order for this to be a winning coalition. So B is critical. And with a little bit of thought, we start to see, well, it feels like, hey, everybody's critical, because as soon as you cross off, like if you cross off G, then you have only R, that they don't have enough. So G is really important. G is critical. And if we cross off R, that's no good. All right, so all of these guys are critical, right? So I'm just going to write all the letters in here. R and G are both critical here. B and G are critical here. And so it's tempting to just say, well, R, B, and G are like everybody's critical all the time, but let's be really careful in this last row. Suppose that we look at R, and I'm trying to decide whether or not R is critical. So I temporarily cross them off, put your finger over R. If B and G are still left, does it pass? Yes. Was R critical in this coalition? No. This coalition could do without R being here. It would still win. So they don't really much care that R was in their favor. It was fine that they were, but they didn't need them. R is not critical here. So we don't put an R over there. And then we can look at B. And I want to point out one really common mistake that I've seen is that people will cross off R and decide that R is not critical, and then they'll continue to cross off. And so now R and B are out, and we say, well, G doesn't have enough to cut it, and so all of a sudden somebody's critical. But it's not true. You just cross off one at a time. So just cover up R, and then once you've decided that R is not critical, bring R back, and then cover up the next one. So you're only covering up one at a time. So let's focus on B. The question is B critical? Well, if we cross them off, does that still win?
Yes.
It still wins. B didn't really need to be here. So is B critical?
No.
No, we didn't need them. And now B is back, and we look at G, and we say, is G critical? Well, put your finger over G. Does that coalition still win? They do. Was it critical that G was here? No, it still wins, even without G's input. So which ones are critical in this last row? None.
You know that player one is not critical, and you know the rest.
That's right. If you know player one is not critical, then nobody else can be, because player one is the strongest one. They have more votes than anybody else. So that is a nice little shortcut. Before you start taking nice little shortcuts, I encourage you to really slowly go through one at a time. Are they critical or not? Bring them back, then do the next one. That's the toughest part, is figuring out who's critical. Okay, number 9 is this process that we're going to learn about here. So we're over to Griffin. Okay, we did that already. That's in the first column. And we did that too. That's in the last column. Okay, so here's the new part. I'm going to write it over here on the side. You can write it down below if you want. So I'm going to list my 3 players here. I've got R, and I've got B, and I've got G. And so the first thing we're going to do is count how many times each player was critical. So R, how many times does R appear in my critical list?
2.
Twice, right? R appears twice. So I'm just going to put a 2 underneath the R. And how many times is B in my critical players list?
2.
Also 2. And G is also 2. Okay, so even at this stage, we get kind of this surprising result. How do the powers of these three people compare to each other? Kind of looks like they're tied. Kind of looks like they're all equal. They're each important, they're each critical twice, which is surprising because green had only 3 votes compared to the 99 votes that red had. But the way it was set up, green was important just as often as red was. So yes, they are all equal, but instead of saying that they're all 2s, and in another example they can be 5s or 50 and hundreds, we want to get it to a percentage. I would really like to be able to convert everything to a percentage so that we can compare and think about percentage of power. So we're going to take each of these guys and we're going to divide by some magic number. And yeah, it just says divide by the total number of times all players are critical. So how many total critical players are there here? Is 6. So each of these becomes a fraction with a 6 in the bottom, each divided by 6. Yeah. And so each of these is a third if you want to reduce. If you prefer percentage, you can say 33.3% for each of them. Yeah, the Banzhaf power index is that.
So for R for Icelandia, our EPI is.
Yeah, their power is 33.3%. So that's it. That's the Banzhaf power index. They each have about 33% of the power, which is surprising, but that's how it worked out. Okay, next page. And we'll go to Sam for 11. Psychiatrist. Mm-hmm. Okay, so we've got the system to try to decide who the Celtics are going to draft first. And each of these 4 different folks has different amounts of votes, and we just need a majority. So first thing is to write this thing in our standard notation. So how many votes are there total? It's 10, and it says that we need a majority. How much is a majority for 10?
6.
Is it 5 or is it? It's 6. It's more than 5, right? 5 is not going to cut it. So 6 is the quota. Strongest person has how many? 4. 2 and 1. Just putting it out there, if you're a Celtics fan, this is going to be a long season for you coming up. Just saying. And I'm going to go ahead and throw out there the same comment for the Patriots fans in the room. You guys are 2-0 right now. You should not get used to that. All right, so here's the system mathematically. So let's find the Banzhaf power distribution. So let's make a table. I mean, it's just a blank space here. So we're going to make a table with the same list that we had before. We want the winning coalitions, and then we needed to know the weights. And then what was that last column? It was really important. It was the critical players. That's the tough part. Okay, and it looks like we can't really do anything fancy here. Like they're saying use P1 and P2 and 3 and 4. So I guess that's what we just have to call them. We're going to fill this in together. Now, just coming up with the winning coalitions is a little bit of a process, and you want to kind of be methodical. So I'm going to share with you what I use. It's not the only way to come up with it, but I would start the same way every time. I would say, is there any single person that has enough power to pass a motion by themselves?
No.
No. But if there were, I would list a single person first. Then I would look for pairs of people. Are there any pairs of people that can pass this thing? Yes, there are. So now we're going to list pairs of people that can pass this thing, and I would just start from the strongest, the leftmost. So can P1 go with anybody and pass this? Yeah, P1 and P. Yes, is there anything else before that we could do? Yeah, so if P1 goes with P2, then how much power, how much weight do they have? Is 7. So that's enough. Anything 6 or more is enough. Okay, and then I'm going to keep P1 here as long as I possibly can. Can P1 go paired, get paired with anybody else? Yeah, we can go with P3. And then we'll have 6, and that's enough, just barely. And the fact that it's just barely probably means we're done listing pairs with P1. But let's just look at the next one. What about P1 with P4? Is not enough. And so we don't list it, but you still have to think about it. P1 and P4, 4 votes and 1 vote is only 5, not enough. Okay, still looking for other pairs. So I have finished looking at all the pairs that start here. So now I'm going to look and see if there's any pairs that start here. So can we pair these 2 people and have enough votes? No, it's only 5. And I feel like there's not even any point looking any further because they get weaker as you go along. And I can't find any other pairs because, again, they get weaker as we go along. So there are a lot of pairs, but those are the only 2 ones that are winning. Okay, we wrote down the singles. There weren't any. Then we wrote down the pairs. Next one are the triples, trios. And again, I would start over and I would just start grouping from the far left. So I would start with P1, 2, and 3. So P1, P2, P3. Does 9 sound good? I think I'm going to run out of room here a little bit, but we'll try to squeeze it in. Okay, other triples. P1, P2, and P4. This is where it gets easy to miss, and you want to really try to be orderly as you run through the possibilities. So P1, 2, and 4, and that's a total of 8. Okay, that's enough. Other triples? Yeah. That's the one that's really easy to miss. What a lot of people would go to next is P2, P3, P4. Is that enough power, enough weight? P2, 3, and 4? They have a total of 6. That's enough, that's fine. But it's really, really easy to miss the one that Chad just shared with us. There's one more that starts P1. It's P1, P3, and P4. It's really easy to miss that one. P1, P3, P4. Sorry, it's so small in there. What's the weight on that? 7. And we've done the trios. And what's left after the trios is the grand, the quads. Any groups of 4? Yeah, the one group of 4 that represents everybody. Okay, 1, 2, 3, and 4. Altogether, they have a weight of 10. Okay, so before we move on to the tough part, getting the critical players, I want to show you a resource in the front of the packet. Ed? The fact is you can do this in any order you want. I'm just presenting, I suggest doing it in some organized fashion so that you won't miss anything. But there is a little backup here that I can share with you to help you not miss anything. So let's take a look towards the beginning of the packet. Let's see if we can find this real quick. If you go back not to page 1, does this not exist? I'm looking for something that doesn't appear to be here. Oh, here it goes. Page 7. You guys jump to page 7. Okay, so here's some good news for you. This Finding the Bonds Off Power Index sheet you can bring with you to our first test.
Really?
This sheet in its entirety you can have with you. It has the process that we just talked about for finding the bonds-off power index. First, you make your list of all winning coalitions, and then you find the critical players, and then you count, and then you divide. It's got it all written out there. But what I wanted to share with you right here was a list of all coalitions with 4 players. This list right here. And you can see how it's organized. Here's all the singles. We didn't need to write any of them down, but there they are. And then there's every possible pair of 2 people from 4. It's just listed right there. And so if you don't have some nice organized way and you're worried you might miss something, you can just have this in front of you.
No matter what the values are?
Yeah, I mean, you put the weights in there, but this tells you like what all the ways are to group these people together. And so, yeah, we did that one, we did that one, we did that one, but it's really easy to miss that one. Chad found it for us. But there's no way to miss it if you just have this in front of you and you check it. Just check every one of those things. It's not that many. There's only 15 of them in this list. So you can just check them. Some of them you can just skip through very quickly because it's easy to know they're not winning. Okay, so that's there. Let's go back to where we were. And now we're going to think about critical players. Okay, so let's do one of these rows together, and then you guys are going to work on the rest in your groups. Okay, I want to pick, what do I want to pick? Let's pick P1, 2, and 4. Let's do this row together. 1, 2, and 4. Okay, so this is the toughest part of the process, so be patient with yourselves. Let's just look at P1, and we're trying to decide if P1 is critical. So I'm going to temporarily cross them off. You put your finger over P1 right now, which means all that's left is P2 and P4. So very carefully add up the weights of P2 and P4.
4.
1 vote for 4. Agree? Is 4 enough votes to pass this thing?
No.
No. So without P1 there, this thing loses, which means P1 is critical. We needed them. So P1 goes in the right-hand column. It's a lot of work to write down very little. All you got to decide is P1 gets written or they don't. In this case, they get written. Okay. Now we uncover P1, we bring them back. Don't cross off 2 players at one time, just 1 at a time. And now we're going to look at P2 and ask if P2 is critical. So put a finger over P2. I will cross them off like this. P1 and P4, carefully add up their weights. That's 5. Is that enough?
No.
No. So is P2 critical here?
Yes.
Yes. We need them, otherwise we lose. So P2 is critical. And who's the only other one we have to think about in this row?
P4.
It's P4. So put your finger over P4, temporarily crossing them off. Carefully add the weights. 7? Yeah. 7 enough to pass?
Yes.
Yes. Is P4 critical?
No.
No. They don't need to be here. It didn't really help that P4 was there. We don't need them. We can pass this thing without P4's help. So does P4 get written down?
No.
No, P4 is not critical there. Right? So it's 1 at a time. Look at each player and decide whether or not each player gets written down. But there's no shortcut here. You just got to look at each player 1 at a time. Okay, so here's the plan. We've got about 30 minutes left in class. You are going to tally your list of critical players here with the help of your neighbors. Then you're going to write down the bonds-off power index, which means those fractions. I wrote them as percentages. You can leave them as fractions if you prefer. And once you finish that and your whole table agrees, move on to this frontier power activity. 30 minutes is maybe enough time to get through all that I am asking. The frontier power activity is involved, so you're really going to need to push and keep going at a good clip here as you work through. Let me know if I can help.